Hi guys, my name is Josh Gangemi and I'm going to describe to you what it's like being a biomedical engineering co-op. My days usually start with me going straight to work from practice. I try and get to work around 9 o'clock. I drive. I usually get to work, sit down at my desk, check my email, and eat breakfast. I eat breakfast at work almost every day. I usually try and get all of my desk work done, like right when I get into the office. Try and ease into the day. At Lyndra, I work a lot with teams, and I love that because it's great to just bounce ideas off of other people and just see how other people's minds work. Here, what I did was I was taking that 3D print and I brought it to our back room where we have all our tools. It's really hard to see, the pieces are so small and the angle's bad, but what I have is 2 pieces that I 3D printed, and I plan to drill holes and then tap those holes so I can screw them together, and that's going to be make our injection mold cavity. Tapping is basically just putting threads into something so you can screw a screw into it. So right there, I'm trying a bunch of different screws. I'm filing down the part so I can get the inside cavity, because a lot of times when you 3D print something, the prints can swell, so it's not the right geometry. I'm filing down the print just to get the right geometry I want so everything fits. So that chart that I keep staring at is actually really important. I learned that the hard way, which you usually do in R&D, but that chart tells you which size drill bit you have to use when you're trying to tap a certain size hole. So if I'm trying to make this tap with these threads, then it's gonna refer me to what size drill bit I need to make. It's super important because if you're tapping something that's steel and you use the wrong size drill bit when you're trying to tap and thread that hole, if you use a drill bit that's too small, you might break the tap, which I've done before. Or if you're using it on if you're trying to tap a 3D printed part and you don't drill the right size hole for the tap, you could end up cracking your part because there's just too much pressure on there. So instead of the tap breaking, your part just cracks. So that's a pretty important chart. Got to pay attention to detail. This machine right here is a drill press. So I'm using this drill press to try and drill a straight hole. I'm trying to set up these 2 little pieces in a vise. It's not going so well because the pieces are so small. But essentially what I'm trying to do is I'm trying to drill perfectly straight holes so I can then tap these 2 3D printed parts. What I'm making here is a makeshift injection molding device. Injection molding is a manufacturing technique where you inject molten material into a cavity or a mold at high pressure. The molds are usually 2 pieces and made of metal. What we were trying to do at this time was join 2 polymers together and have a good end product that retains a very specific triangle geometry. Those little printed parts were the mold cavities where I planned to attempt to inject molten polymer onto another non-molten polymer that would already be sandwiched inside the cavity. It actually worked very well,
The only problem was the molten polymer stuck to the 3D printed parts more than the non-molten polymer, and ended up getting ruined when I tried to take it out of the mold. This is why professional injection molds are made of metal and usually use mold release agents. We were just trying to test a quick theory, which is why we use 3D printed parts for a makeshift injection mold.
Overall, I think co-oping at Lyndra has really prepared me for the professional world. I'm so grateful that they've kept me on for the past year. Through that year, I've learned so much as technical engineering skills, but also professional skills as well, whether that be time management, prioritizing projects, problem solving, or coming up with novel experiments to solve problems. I haven't even graduated yet, and I feel like I'm already an engineer.